In this video, we'll generate the trend line and polynomials of x to the power m times the quantity 1 minus x to the power k plus 1 over 1 minus x. So we begin with the dataset. So array formula of the x values raised to the power m times the quantity, that's 1 minus x to the power k plus 1. So 1 minus x raised to the power k plus 1, the quantity k plus 1, k plus 1, and close parenthesis, divided by 1 over 1 minus x. So 1 minus x, that's the denominator, and enter. And the values of m and k, so data validation over the range from 0 to 8, and hit save. So we can start with 0 and 0. We can go to 1 and also 1. And we continue with the Taylor Maclaurin SERIESSUM expansion, which is the summation of x to the power n, from where n is from m to k to m plus k. So this will be sequence of m k plus 1, one column starting from m incremented by 1, and enter. So if this is 0, 0, if this is 1, and this is 2, this is 1, 3, so it starts from 1. So if this starts from 2, then 2, 3, 4, 5. If this starts from 3, then 3, 4, 5, 6, so 3 to 6. And the value of a, which is 1, so this is equal to array formula of the values of m raised to the power 0, and enter. Now if this is empty, this should be 0, so we correct that. So if this is empty, then 0, then empty, oh yeah, 0. Otherwise, d2 to d3 to d22 raised to the power 0. Now it's corrected. So if this is empty, this should be 0. Now the series sum, the Taylor series expansion. So array formula, series sum of the x values raised to the power n, where n starts from k incremented by 1, and the coefficient will be this range. And we chart this. Insert chart and use scatter chart. Column is label. We don't need a title, so delete this. And for the series, show the trend line. The type polynomial. The degree 8. For the label, use the equation. For the legend, position at the bottom. So here's our trend line and polynomial. We'll calculate this polynomial regression coefficients using LINEST. To do that, we complete the LINEST matrix starting with the power. So the 0 to 8. So this will be array formula of the x values raised to the power 0 to 8. And now we use LINEST. So LINEST of the function data y. This will be our data y. and dot x. That's for the function itself. For the expansion, LINEST dot y and dot x. So let's compare. Let's start from all the values to 0. 0 and 0. So m and k are 0. That's 1. So this is 1. So at m equals 1. So we have values of x. So at k equals 1, then it is x plus x squared. So that's x plus x squared. The rest are 0 because they are very small. At k equals 2, that's x plus x squared plus x cubed. That's x plus x squared plus x cubed. The rest are 0. K equals 3, that's x plus x squared plus x cubed plus x to the fourth. K equals 4. That's x plus x squared plus x cubed plus x to the fourth plus x to the fifth. Same thing with this one. X plus x squared plus x cubed plus x to the fourth plus x to the fifth. Suppose I assign m equals 2. We start from 2. So start from 0. That's x squared. At k equals 1, that's x squared plus x cubed. So x squared plus x cubed. K equals 2. Then that's x squared plus x cubed plus x to the fourth. X squared, that's x squared plus x cubed plus x to the fourth. K equals 3. Now this is x squared plus x cubed plus x to the fourth plus x to the fifth. So x squared plus x cubed plus x to the fourth plus x to the fifth. And k equals 4. Now this is x squared plus x cubed plus x to the fourth plus x to the fifth plus x to the sixth. X squared plus x cubed plus x to the fourth plus x to the fifth plus x to the sixth. Suppose I go as far as 3. So you can start from 0. That's x cubed. Then k equals 1. Then that becomes x cubed plus x to the fourth. So x cubed plus x to the fourth. X cubed plus x to the fourth. K equals 2. Now it's x cubed plus x to the fourth plus x to the fifth. So x squared plus x to the fourth plus x to the fifth. X cubed plus x to the fourth plus x to the fifth. K equals 3. Now we have x cubed plus x to the fourth plus x to the fifth plus x to the sixth. X cubed plus x to the fourth plus x to the fifth plus x to the sixth. That's x cubed plus x to the fourth plus x to the fifth, x to the sixth. This completes the use of Taylor Maclaurin series sum to generate the trend line and polynomial of this geometric series finite sum, where the values of n is from m to m plus k, and the equation is, or the polynomial is, x to the power m times the quantity 1 minus x to the power k plus 1 over 1 minus x.